When you run Claude Code once on a hard problem, you get one answer. That answer is probabilistic. Run the same prompt again and you get a different answer. LLMs are nondeterministic. That means running once is not running. It is sampling once from a distribution and committing to the result. Git Worktrees let you sample the distribution properly. A Git worktree is a separate working directory linked to the same repository but checked out to a different branch. You can have 3 worktrees, trees/uiwrite1, trees/uiwrite2, trees/uiwrite3, each a full independent copy of the codebase on its own branch, each able to run its own server on its own port. This is not a new feature. Git has had worktrees since 2015. The new part is running a Claude Code agent inside each one. The setup command, you create a custom / command that calls git worktree add for each parallel environment, copies environment files, installs dependencies, and updates the Vite config to run on a distinct port. Claude Code on Opus handles the orchestration. The result, 3 independent codebases, 3 running servers, all isolated, set up in under 5 minutes. The execute command, you pass it the plan file and the number of agents. Claude Code spins up 3 parallel subtasks, 1 per worktree, each receiving the same spec and told to implement it independently in its own codebase. You set auto-accept mode and walk away. Each agent runs 5 to 15 minutes. Each produces a working implementation with a results summary. 3 agents finish. Agent 1 ran 9 minutes, 80,000 tokens, terminal-style dark theme. Agent 2 ran 5 minutes, 67,000 tokens, modern blue highlight, clean layout. Agent 3 ran 14 minutes, 110,000 tokens, compressed information dense design. You boot all 3 on different ports and compare them in the browser. You are not choosing which agent was cheapest. You are choosing which feature of your code base is best. You pick agent 2, you commit the branch, push it, then git merge it into main. That is 630 lines of agentic changes merged in, all from a spec you wrote, not from you touching the implementation. The key constraint, you need a clear plan to make this work. If you cannot write the spec, you cannot run the parallel workflow. The spec is the work. Use parallel worktrees when the task is hard enough that one agent might fail, multiple acceptable implementations exist, or you want diverse perspectives on a design decision. Do not use it when you are iterating on a bug fix, the task is a one-liner, or you have not written a spec. Without a clear plan, you get 3 versions of confusion. With a clear plan, you get 3 shots at the best answer. Here is what the evidence shows. Your turn, find the hardest open task in your backlog, the one where you are not sure which implementation path is right. Write a spec for it. Then run 3 agents in parallel worktrees and compare the results. You are not writing code. You are running the experiment and picking the winner.